Hello everyone, and welcome to this theory recording on charge and current. So what is defined as charge? Charge is an electrical property of particles consisting of matter, and it is measured in coulombs. It's important to remember the equation for charge, which is that the cumulative charge, denoted by capital Q, is given by the integral from t0 to t of the current with respect to time. So it will be the integral from t0 to t of I dt. You'll remember from either other modules, so physics or high school subjects, that we also denoted charge as, or the charge at one point, cumulative charge, as the current multiplied by the time. So that will be the current in amperes multiplied by the time in seconds. What about electric current? Electric current is defined as the time rate of change of charge, and that is measured in amperes. So from that definition, we should be able to pick up that the current is equals to the rate of change of charge with respect to time, or the derivative of the charge with respect to time. Again, from previous modules, you would have remembered that we would have said that the current is equals to the charge divided by the time. That will be at any fixed particular instance. We work with two types of current. The first is direct current. So you can see with direct current on the figure on the left that the current remains constant with time, whereas with alternating current, the current changes. It's a sinusoidal signal that changes as a function of time. What about voltage? Voltage is defined as the energy that is required to move a unit of charge through an element, and that is measured in volts. This is also known as potential difference. So the amount of work or energy that's required to move a unit of charge from one point to another, for example, from point A to point B in the diagram. The equation for voltage can be given as the rate of change of work with respect to charge. So V is equals to dW dQ. From this diagram, it's important to also note polarity, which we'll talk about. So the voltage is generally with reference to a ground point, and a ground point is a reference point that has 0 volts. Whereas a potential difference would be indicated from one point to another. So the voltage VAB is the potential difference from point A to point B, whereas the voltage VA is the voltage at this point with respect to a ground point, which in this case we could also call VB. So in this case we could say VA is equals to VAB. So the potential difference and the definition of the voltage is exactly the same. The next section we're going to look at is polarity and passive sign convention. This is extremely important as it will denote the polarity of elements that you're going to be using, as well as the direction of current that will be flowing in any circuit. So let's take a look at a circuit. This consists of a voltage source. Let's put a capacitor, and let's put an inductor. So typically in a circuit that is closed with a source, current will flow in a passive sign convention direction. That means from the source around the circuit all the way back to the source, from the positive of the source around the circuit all the way to the negative of the source. And in doing so, it assigns polarity to the elements that are connected to the circuit. So because of the current flow direction, the polarity will then be assigned to the elements. Thank you for watching this video and enjoy the course.